Okay guys, this is our first video together. So what we're going to do is we're going to just remind you that you can stop the video at any time. If I'm going too fast, I do go kind of quickly on these videos because I know you can stop them and get caught up. So please stop them and rewatch them so that it makes sense. Okay, complex fractions is just division. That's all it is. So it's just a fancy way of writing division. This is negative 1/8 divided by 1 over 72. That's what that means. And of course, now we have to do the division. And to do division, of course, we flip the second one and change it to multiplication. We can cancel, divide out common factors if we want or not. And this one we're going to get negative 9 for our answer. There you go. All right, the second one, I'll do it again. Again, if you need to stop the video, please feel free to do this. This is really 16c to the 4th d to the 3rd over 5c divided by 4cd to the 4th over d to the 2nd. And in division, to divide by a fraction, we flip it and change it to multiplication. All right, now this one's a little more complicated. I'm going to factor all these out or write them out in their factored form so that I can see what I'm dealing with. That's the first fraction. And then the second one has 2 d's. There we go. All right, so now when I go to start looking for things to cancel out, it's a little easier. There's a 1 right there. There's a 1. There's 2 here, and that makes a 1. There's a C here. There you go. There's another C. There it goes. Now, that's all that cancels out. So let me, I think. Yep, let's see what I have now. I have 16 C to the 2nd D on top and 20 on bottom. I'm going to say there's something wrong with this. Nope. Nope, that's right. And so then when I reduce my numbers, I'm going to get 4 over 5 C to the 2nd D. And that's my answer for that one. All right, same thing for number 3. This is just a division problem. So I'm going to rewrite this as y plus 2 over y minus 5 divided by y squared minus 4 over y squared minus 25. Now, remember when we did these, if they could be factored, we factored and flipped. So I'm going to factor and flip for these because they are factorable. So that's going to give me a y minus 5 and a y plus 5 in my numerator, and a y minus 2 and a y plus 2 in my denominator. I factored and flipped. Stop the video if you're not sure how that factored or where all that came from. Stop the video and figure that out. All right. Now I'm going to cancel out my common factors. I have a y plus 2 and a y plus 2. That makes a 1. And then I have a y minus 5 over y minus 5, and that makes a 1. All right, and so then my final answer is going to be y plus 5 on the top and y minus 2 on the bottom. Okay, so what we have here is a little bit different situation. These problems have addition and subtraction problems with fractions in their numerators and denominators. So what we're going to do is we're going to do the addition and subtraction in the numerator, do the addition or subtraction in the denominator, and then we will have a division problem. So here we go. Let's look at this. So for this first problem, I've got to do 1 over 100 minus 1 over x squared. Now the first thing I need to do is get the common denominator. And some of y'all are getting good at this. so that would be 100x squared. Now remember, we look to see what's missing. So over here, we're missing an x squared. And over here, we're missing a 100. So my numerator for my new fraction is going to be x squared minus 100. All right, so that's basically what I did, was added the two fractions together in the numerator. So now I'm going to add the two fractions together in my denominator. Again, I know what my common denominator is. It's going to be 10x. And so then I'm going to look and compare and see what's missing from the first one. Well, that was just an x. And then in the second one is a 10. What I do to the bottom, I do to the top. And so now my new denominator is going to be x plus 10. Change colors. X, whoop, come on, change color. X plus 10. All right, so now this is a division. So now we can change this to a division problem. So that we have x squared minus 100 over 100 x squared divided by x plus 10 over 10x. That's our division problem now. So now we will factor that one. X minus 10x plus 10 over 100x squared. 10x over x plus 10. We will cancel out our x plus 10s. And we can cancel out the x here with 1x here. And then we've got 10 times x minus 10 over 100x. And I think I can reduce that. I know I can. And so my final answer would be x minus 10 over 10x. Yes, that's a little complicated, and this problem can be done a different way, but if you're good at the adding and subtracting, which y'all pretty good at the adding and subtracting, then this might just work. Number 5 here, I'm not going to do. I decided that one just needs to go away. Okay, so we're going to do this one like we did the other one. We've got an add problem in the top, but if you'll notice in the bottom is already a single fraction, so we're not going to do anything with that one. That one is already a single fraction. But this numerator we want to put together. And so again, we're going to get our common denominator. Our common denominator is x. And if we'll look at the first fraction, we don't need to make any changes to the first fraction. But the second one, we'd need to multiply by x and need to multiply by x. So that's going to give me, in my numerators, a 2 plus x squared. And that's my numerator. And then my denominator is x plus 2 over 2. Now this is officially a division problem. So I have 2 plus x squared over x divided by x squared plus 2 over 2. And we know we've got to flip this guy. It does not factor, so stop trying to factor it. I didn't flip it. Let's do this. There we go. Now it's flipped. And there we go. So now, do you notice something? X plus 2 and 2 plus x squared, or x squared plus, these are the same. Those are the same. And so those are going to get to cancel. And so now my answer is just 2 over x.